Good evening students, welcome to Yupp Master. I am your chemistry teacher Dr. Sripad Rao. So we are looking into the alkanes, and in the last class we have discussed about the hybridization, the structure of alkanes, the natural sources from where we are going to get the alkanes. Alkanes are obtained from the petroleum as well as natural gases. Petroleum is a complex mixture of hydrocarbons. Natural gas is also a complex mixture of hydrocarbons, but of course 80% of that natural gas is consisting of propane, and the remaining the methane, and the remaining things are remaining ethane, propane, butane are present around 20%. And if you look at the structure of alkanes, the carbon atoms in the alkanes are undergoing sp3 hybridization, and thereby they are giving us the tetrahedral geometry with the bond angle of 109 degrees 28 minutes. Okay. So, that what we have seen in the last class, and we are supposed to name these alkanes. So, in order to name the alkanes, as we have discussed in the last class, so the names of alkanes can be given by two different methods. One is the common method of nomenclature, okay, common method of nomenclature, whereas we have the other one, the systematic way of naming, IUPAC method of nomenclature, IUPAC method of nomenclature. So here the common naming system is also called as trivial method or trivial names. And generally the common names and trivial names are observed or taken from the sources from where the compounds are obtained, or the areas from where these are obtained. So based on that they have named accordingly, and of course it leads to the common method or the trivial method of naming the alkanes will lead to a confusion, because we have a huge number of organic compounds, and day by day the number of organic compounds are increasing. As the number is increasing a lot, so the common naming system becomes a little tricky in order to identify these compounds. So therefore we focus on the IUPAC method of nomenclature, and the IUPAC naming is a systematic naming, and based on the number of carbon atoms present in the compound we name the alkanes, and from that it is easy to identify them, and even if the name is given we are going to write the structure. So according to IUPAC nomenclature, according to IUPAC system of nomenclature, one structure will have one name. One name corresponds to only one structure. So wherever you go, the name of the organic compound according to the IUPAC system will give only one structure. One structure, that particular structure will have only one name according to IUPAC. But according to the common naming system, we have different namings. For example, in the case of methane, CH4 is taken as methane. Methane is also known as marsh gas, since it is obtained in the marshy places by the anaerobic decomposition from the bacteria, and even it can also be called as fire damp. So the different names are given for the same molecule. So fire damp means CH4, marsh gas also means CH4, methane also means CH4. So that is a problem with respect to the common method of nomenclature, or the trivial names that are given to the organic compounds, and in order to give a systematic naming we use the IUPAC system. So let us today focus on the common naming system, and then we will move on to the IUPAC nomenclature of alkanes. Okay, right. In trivial system, in the common system, in the common nomenclature, common names that are given to the organic compounds. So how to name them? Generally, whenever we have a unbranched alkanes, when there is no branch present in the molecule or the alkane, saturated, open chain, hydrocarbon, when all the carbon atoms are present in a line, in a straight line, in a straight chain, in that case when there is no branch, unbranched alkanes, generally we use N. N indicates normal. So here we write N. N is to say that it is a normal. Normal means no branching at all, unbranched alkane. All the carbon atoms present in that particular chain are present in a straight fashion. There is no branching at all. Here and there is no branching present. They are called as unbranched alkanes. So, unbranched alkanes according to the trivial naming system or common naming system, we use the word N. N to indicate the unbranched alkanes, right. For example, if we have CH3, CH2, CH2, CH3. So, we have 4 carbon atoms in the chain and all the carbon atoms are present in a straight fashion, no branching, no here and there is no other carbon attached. So, we have a straight chain. So, we call it as N-butane. Here N indicates that it is a normal unbranched chain of carbon atoms present in alkanes. It is an unbranched chain. So, unbranched chain present in alkanes that can be named in a common system by using the prefix N. N indicates normal unbranching system. Similarly, if we write CH3, CH2, 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 CH3. So, we have 5 carbons arranged in a straight fashion, no branching at all, unbranched 5 carbons in a straight line. So, it is N-pentane. So, we use the N to indicates normal pentane. Okay. So, N is used whenever we have an alkane, that alkane is unbranched, no branch is present and all the carbon atoms in that alkane are arranged in a linear fashion, in a straight fashion, only one direction and there is no branchings present here and there. Unbranched alkane chain, if it is present, we use the prefix N. Okay. Right. In the case of when we have an alkane, but if a methyl group is present on the second last carbon atom of the parent chain and there is no other substituent that are present. So, we have to take, for example, in this case if we observe, so we have a 3 carbon chain, a straight chain is present, okay, and we have a methyl group here. So, from any one end, the second last carbon, this is the last carbon, okay, this is the last carbon atom, this is the last carbon atom and this is the second last carbon atom, okay, second last carbon atom. So, whenever we have a methyl group at the second last carbon atom from any end of the chain and moreover there is no other substituents present on that chain, no other substituents are present, only one substituent is present, that substituent is methyl and that too that methyl is present on the second last carbon atom, it is present on the second last carbon atom. In that case we are going to use the prefix iso in trivial naming system or common naming system. Whenever we write iso, it indicates that in a straight chain from any one end if you select, the second last carbon atom possesses one substituent, that is methyl substituent. CH3 is present in that on the second last carbon atom. So, that is taken for that compound we are going to use iso prefix. So, here how many carbon atoms are present? We have 4 carbon atoms and this is the second most or second last carbon atom from here or from that side, you can take from any side, okay, and on that we have a methyl group. So, therefore, it is taken as isobutane. So, isobutane means 3 carbons are in one straight chain, whereas one CH3 is present on the middle carbon, or you can take from one end the second last carbon atom if it has a substituent of methyl CH3. CH3 is called methyl. Here we say that alkane, okay, when we have an alkane, but when you remove one hydrogen, removal of one hydrogen from alkane, alkane minus hydrogen will give us alkyl, it is give us alkyl. So, methane removing one hydrogen, it becomes CH4 becomes CH3. So therefore CH3 is called as methyl alkane. On removing one hydrogen becomes alkyl. Methane becomes methyl. Ethane becomes ethyl. Propane becomes propyl. Butane similarly becomes butyl. We will discuss that one also. Okay, right. So it is isobutane. Here we are using the term iso only because of the presence of a methyl group on the second last carbon atom from any end of the chain, and there are no other substituents present on that particular carbon chain or the parent chain. That you have to be very careful. Look at this one. So here if I go from here this side or from this end, if I am going from this end, this is the second last carbon atom. On the second last carbon atom we have a methyl group. On the second last carbon atom we have a methyl group. So here the methyl is present on the second last carbon atom, and look at the total number of carbon atom, 5 carbons are present, so it is called as isopentane. So this moiety presence of one methyl, that is CH3 group on the second last carbon atom from any end of the alkane chain, and moreover no other substituents are present, that particular alkane is given a prefix iso. So since 5 carbons are present, it is called as pentane, and since one methyl is present at the second last carbon, so we call it as isopentane. It's an isopentane. So iso terminology is used whenever we have a methyl group at the second last carbon atom of the parent chain. Right. In this case also if we observe, we have a 5 carbon chain, straight chain, but one methyl group is present, one CH3 group is present on the second last carbon atom. So on second last carbon atom, okay, on second last carbon atom we have a methyl group CH3. Okay, so therefore we are using this iso. How many number of carbon atoms present in the total? In total if we observe, total 6 carbons are present, so we call it as hexane. So it is an isohexane. Okay, so the iso terminology is given only for those compounds in which one methyl group is present on the second last carbon atom from any end of the chain, parent chain, and no other substituents are present on that particular chain. Okay, right. So here we are going to denote the iso prefix in that alkane where we have a structural unit of CH3 taken 2 times CH at end of the parent chain. So one of the end of the parent chain we are going to have CH3 taken 2 times CH. If that is present, we call it as iso. For example, in this case CH3, CH, CH3, CH3. Okay. So if we observe here, this is the second last carbon, one side we have a CH3, other side also we have a CH3. So I am reducing the number of times writing this particular CH3, so I am writing it as CH3 taken 2 times, CH3 taken 2 times, then CH. So it indicates that these CH3s are attached to this carbon. So these 2 CH3s are attached to this carbon. So if you observe here the connectivity, so this is one connectivity and this is other connectivity. So CH3 group attached to CH, CH3 group attached to CH. So CH3 taken 2 times CH. If this is present, so presence of this particular CH3 taken 2 times CH structural unit at one of the end of the carbon chain. Okay, one end of the carbon chain, then that particular compound we use the term prefix iso. So prefix iso is used for an alkane which contains CH3 taken 2 times CH structural unit at one of the end of the carbon chain and no other substituents are present on that particular carbon chain, then it is advisable to use the prefix iso. Don't confuse. Iso means we have one methyl group on the second last carbon atom, first thing. Okay. So when you observe this particular compound, at the second last carbon atom we have a methyl group. When you observe here we have one methyl and this is substituent is one methyl. So in order to write these two methyls I am taking CH3 and taking 2 times with a CH. It indicates that CH3 taken 2 times CH if it is present at one of the end of the carbon chain, then iso is generally used as a prefix to in a trivial system of nomenclature or common naming of the hydrocarbons alkanes, right. We also use the neo. Neo system of nomenclature is used for those alkanes which possess 2 methyl groups on the second last carbon atom from any end of the carbon chain and no more substituents are present on that particular carbon chain. Okay. So in this case neo prefix is used for the alkanes in which the second last carbon atom from any end you can choose. Okay. If that carbon going to contain 2 substituent, that 2 methyl substituent, 2 CH3s are present on the second last carbon atom, in that case that neo terminology, neo prefix is used for these alkanes. Okay. For example, if we are going to write a CH here, CH3, so already we have a 3 carbon chain, let us say CH3s, CH3, CH3, straight line I am writing. On the second last carbon atom I am attaching 2 methyls. So here I have 1 methyl and the second methyl. So 2 methyl groups are present on the second, this is the second last carbon atom, okay, second last carbon atom, because this is the last carbon. If you come from here, this is the last carbon. So second last carbon atom, if it is going to contain, if it is going to possess 2 methyl groups, in that case and no other substituents are present, then it is possible for us to use the terminology neo. So neo terminology, neo prefix for the alkane is used when second last carbon atom contain 2 CH3 groups. If it possesses 2 CH3 groups, then we use neo. And in this case, if you observe the number of carbon atoms, total we have 5 carbon atoms. 5 carbon atoms, so it is neopentane. It is known as neopentane. So neo terminology is used for the alkanes which possess 2 methyl groups on the second last carbon atom. You can go for any end, okay. You can start from this end or the other end, but the 2 methyl groups should be present as a substituent on the second last carbon atom from one end, and no other substituents are present on that carbon chain, alkane chain. In that case, neo prefix can be used to indicate the compound. So here if you write, here 5 carbon atoms, 2 methyl groups are present on the second last carbon atom. So we are using neo with a 5 carbon chain, so it is a pentane. Similarly, we can also use CH3, 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 CH2, CH3. In this case, if we observe, so if I go from this end, 4 carbons are in a straight chain and we have a 2 methyls on the one of the carbon atom. If I go from this side, this is the last carbon atom, okay, the last carbon atom, and this is the second last carbon atom, second last carbon atom. So second last carbon atom, if it is going to possess 2 CH3 groups, then in that case neo prefix can be used to look at the total number of carbon atoms, 6 carbons. So we call it as neohexane. Neohexane. So the presence of 2 methyl groups on the second last carbon atom of an alkyne chain from any end, and there is no other substituent present on that particular alkane chain. In that case, the common system of nomenclature, neo can be used as a prefix with the alkane name, okay, neopentane and neohexane, right. So neo terminology is used only because of the presence of the 2 methyl groups on the second last carbon atom of the alkane chain, okay. right. So, here the neo indicates in the alkanes where the alkanes possess this particular CH3 taken 3 times CH2 structural unit. For example, if we observe the neohexane, in that case, so neohexane 4 carbons are in a straight chain fashion, and we have 2 methyl groups as substituents, and the 2 methyl groups are present on the second last carbon atom of the alkane chain, and therefore it is advisable for us to use the prefix neo. So, here writing neo, and if you observe the second last carbon atom, the second last carbon atom, it is connected to CH3, connected to CH3, connected to CH3. So, we have 3 CH3s attached to the second last carbon atom. So, if I simplify in writing this particular structural formula, so I can write it as CH3, since we have 3 CH3s, so I am writing it as taken 3 times, CH3 taken 3 times, and this carbon, what does it indicate? To this particular carbon, the 3 CH3s are attached. To this particular carbon, the 3 CH3s are attached. So, I am taking the 3 CH3s and keeping as one fragment and taking it as number of times it is present, 3 times, and then carbon, okay. And then what we have? We have the CH2. So, here the structural unit presents CH3 taken 3 times CH2 at one end of the parent chain, then the terminology prefix neo is used. So, we are using neo means it indicates that the alkane has a structural unit CH3 taken 3 times with a CH2 bond, and in that case that end, one of the end contain this particular structural unit, the CH3 taken 3 times, CH2 is present at one end of the parent chain. It indicates that neo is the name or the prefix that we are going to use for that particular alkane. So, alkanes having the structural unit CH3 taken 3 times CH2, this one CH3 taken 3 times CH2 at one of the carbon chain or end of the carbon parent chain, then neo is used, or if it neo is given means this unit is present, okay. Right. Just make a note of the prefixes usages where we are going to use. So, for example, in the case of prefix iso, where we are going to use prefix iso is used when one methyl group is present on the second last carbon atom from any end of the parent chain and no other substituents are present on that parent chain. In that case, we use the prefix iso. So, prefix iso is used in for alkanes, and it has restricted the usage of prefix iso where the alkane chain contains 4 to 6 carbon atoms only. We cannot use the iso terminology for carbons having 1 carbon, alkanes having 1 carbon atom, 2 carbon atoms and 3 carbon atoms. We are not going to use the iso prefix, okay. So, iso prefix is used for the alkanes having the carbons 4 or alkane with the carbon atoms 5, alkane with the carbon atom 6. So, for alkanes having 4 to 6 carbon atoms only, the prefix iso is used. For higher members like 7 carbons or 8 carbons, the prefix iso is not used, okay. And similarly, in the case of prefix neo, whenever we are using the prefix neo, neo is restricted only to pentane as well as hexane. Only a 5 carbon alkane as well as 6 carbon alkane, we are going to use the neo terminology, neo prefix. For other alkanes having more than 6 carbon atoms or 7 carbon atoms, in that case we are not going to use this neo. Neo terminology restricted to pentane and hexane only. Iso terminology restricted to the alkanes having 4 carbons or 5 carbons or 6 carbon atoms, okay. So, alkanes having 4 to 6 carbon atoms, the iso terminology is used, and the alkanes like pentane 5 carbons as well as 6 carbons, for those 2 compounds only the neo terminology is used, okay. This you have to keep it in mind, students. These two very important: iso usage and its restriction, and neo usage and its restriction. Okay. Yeah, according to IUPAC system, how we are going to name these alkanes? So alkanes are named according to IUPAC by using the root word alk, and we are going to use the suffix ane. Here ane is used in order to indicate saturation or present in the compound. So there are no double bonds and triple bonds that are present in the moiety. So whenever we have a compound in which all the carbon bonds are single bonds, that are sigma bonds, in that case we use the suffix ane. ane indicates that saturation is present in the organic compound. There is no unsaturation. For suppose we have an unsaturation in the compound, and that too the unsaturation is due to the presence of carbon double bond, in that case we use the terminology or we use the suffix ene. ane for alkanes, ene for alkenes. In both the cases the alk will remain the same, but ane is added to indicate the saturation, whereas ene is added to indicate the unsaturation. And if we have an unsaturated compound in which carbon are linked by a triple bond, carbon are linked by a triple bond, we use the terminology YNE. We use the terminology YNE, alk plus YNE, alkyne. So the terminology ANE, ENE, YNE is used to indicate the saturation and unsaturations. For saturated compounds we use ANE. For unsaturated compounds we use ENE as well as YNE. If we have only the carbon single bond, we use ENE. If we have a carbon triple bond, we use YNE. So ANE, ENE, YNE. Therefore the corresponding compounds are called as alkanes. Alkenes if we have a double bond. Okay. If we have a triple bond, they are called as alkynes. So alkanes, alkenes, alkynes. So ANE, ENE, YNE is used to indicate saturation and unsaturation present in the given hydrocarbons. Okay. So here alkanes with the named as root word alk plus suffix with ANE. So here the root word will indicate the number of carbon atoms that are present. Root word alk, we are going to write now all the names of these hydrocarbons up to 10. So here the carbon atoms number is indicated with this root word alk, and the suffix ane is used in indicating the saturation, that is the hydrocarbon, given hydrocarbon is a saturated hydrocarbon, and this particular compound is a member of alkane family. Able to understand, students? The root word alk will indicate the number of carbon atoms that are present in the given compound, and we are using the suffix ane. So here the suffix ane is used to indicate the saturation present, and moreover it says that the compound belongs to alkane family. Okay, it is a member of an alkane family. So here the root word usage is very important. It depends upon the number of carbon atoms. So depending on the number of carbon atoms present, we use different root words to write the IUPAC name of alkanes. That is the standard naming of the hydrocarbons. Okay. So when you look at the first 4 members of the alkane family, their names are generally given by the trivial or common names. So the common names as well as the IUPAC both are using the same for the first 4 members of the alkane family. The first member of the alkane family is methane, that is CH4. Methane, according to IUPAC as well as according to the common naming system, it is given as methane. Ethane, C2H6. Similarly, propane, C3H8. Okay. butane C4H10. So here all the first four members methane, ethane, propane, butane. The common naming and IUPAC both use the same words, that meth, eth, prop, but. Okay, and from fifth member onwards we are going to use the root word, which is going to be obtained from the Greek letters. For example, we are going to use pent for 5 number of carbon atoms. If the alkane has a 6 number of carbon atoms, we use the hex. If the carbon chain contains 7 carbon atoms, in that case we are going to use hept. So here we are going to use the Roman numericals for writing the names of alkane family members from the 5th member onwards. But first 4 members, the names are given with the trivial or common names. So you should be very careful in identifying the name and the number of carbon atoms. Of course, let us write all the names of these compounds so that you can easily understand and you can easily remember also. For example, when we have only one carbon atom in the alkane chain, so in that case we know that the carbon is a tetravalent, it can form 4 bonds. So number of hydrogens will be 4 in this case, and we know the general formula is given as CnH2n plus 2. So based on the n value, here n can take the value 1, 2, 3, 4, 5, etc. Okay, n can take the value 1, 2, 3, 4, 5, etc. So when n equal to 1, C1H4, CH4. So here we are using the name meth. Meth is going to indicate the root word. Okay, the root words for the first 4 members are taken with the common system, and the 5th member onwards we are going to use the Greek numericals in order to indicate the root word. Root word always going to give us the number of carbon atoms present in the chain. Okay, so it is CH4 is meth. Let us take n equal to 2. In that case we have C2H6. So it is CH3, CH3. Ethane. So it is root word is eth. Okay, and when we n equal to 3, C3H6. So C3H6 I can write it as CH3, CH2, CH3, CH3, CH2, CH3. So one CH2 is present between 2 CH3 groups. Okay, and here we write it as prop. So the root word is prop. Okay, and similarly when we have n equal to 4 carbon atoms are 4 carbon atoms are present in the moiety, in that case hydrogen number will be 4 2s are 8 plus 2 10. So we write it as CH3, CH2, CH2, CH3. So here I am writing the number of hydrogens in order to satisfy the tetravalency of carbon atoms. So if we observe the carbon atoms, each carbon atom having 4 sigma bonds. Each carbon will have 4 sigma bonds. So in order to satisfy the number of sigma bonds, I am writing the hydrogen number. Okay. So here it is C4, H10 is the general formula, CH3, CH2, CH2, CH3. So we have 2 CH2 moieties in between the CH3. So we can also write this particular compound as CH3, CH2 taken 2 times CH3. Since CH2 repeated 2 times, so I am writing it as CH2 taken 2 times, CH3, CH2 taken 2 times and CH3. So this is but. Okay, so root word becomes but. And in case where we have n equal to 5, that is number of carbon atoms are 5. So C5 H10 plus 2, 12. So total is C5 H12. So in that case we can write it as CH3, CH2, 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 CH3. CH3, CH2, 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 CH3. So if we observe 3 CH2s are present between the terminal CH3s, and if you observe number of carbon atoms are 5, number of hydrogens are 12, and this case we are going to use the root word pent from Greek numerical. Okay. So, all are saturated hydrocarbons, so we can write it as ANE, 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 ANE. So, when you add meth plus ANE, methane, eth plus ANE, ethane, probe plus ANE, propane, but plus ANE, butane, pent plus ANE, pentane. So, the alkane having one carbon is methane, alkane with the 2 carbon atoms is ethane, alkane with the 3 carbon atoms is propane, alkane with the 4 carbon atoms is butane, alkane with the 5 carbon atoms is pentane. So, writing the first 4 members, their root word is taken with a common system, but from 5th carbon onwards, the 5th member onwards of the alkane moiety, we are going to use the root word from Greek numericals based on the number of carbon atoms. 5 for penta, okay, 6 for when we use the term hexa, okay. Similarly, we are going to write the names for other 5 members as well, okay, right. In this case, now we have a general formula CnH2n plus 2. So far we have discussed up to n equal to 5. Now let us look at n equal to 6. So when we have 6 carbon atoms, 6 2s are 12 plus 2, 14. So it is C6H14. So therefore I am writing it as CH3, CH2, CH3. I am reducing the number of writing the CH2s. How many CH2s are present in between? We have around 4 CH2s in between the 2 CH3s. So when I go for the elaborated structure of this particular compound, it will be CH3, CH2, 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 CH3. So in between the CH3 we have 4 CH2s. It has 6 carbons, 1, 2, 3, 4, 5, 6. 6 carbon atoms are present, and the total, if you observe, 14 hydrogens are present. So we have 1, 2, 3, 4 CH2 moieties in between the 2 CH terminal CH3s. So therefore I am writing CH3, CH2 taken 4 times. CH how many times it is present? It is present for 4 times between these 2 CH3s. So here 6 number, if you observe in the Greek numerical, it is hex. It is hex. The root word is hex according to the Greek numerical. And if we have n equal to 7, when we have n equal to 7, so 7 number of carbon atom, 7 2s are 14, 14 plus 2, 16. So 16, C7H16 is the formula for carbon having 7 carbon atoms in the alkane family. So if I write this one CH3, CH2 taken 5 times CH3. So I am reducing the number of CH2s writing in between the 2 CH3s. Already we have 2 CH3s, terminal CH3s. So 2 carbons are over. How many remaining from 7? 5 are remaining. So I am writing CH2 taken 5 times. 5 carbons, 6th carbon and 7th carbon. Total 7 carbon atoms are present, and each carbon here is satisfying the tetravalency. All sigma bonds are present, and whenever we have a compound alkane with a 7 number of carbons, so we use the term root word as hept. Hept, H-E-P-T, hept, hex for 6 carbons. Similarly, if you observe the carbon number is 8, when n equal to 8, n equal to 8 and hydrogens will be 8 2s are 16 plus 2, 18. So the number of carbons and hydrogen when they are written by satisfying the tetravalency of the carbon atom, we can write the formula as CH3, CH2 taken 6 times and then CH3. So 6 CH2s are present between the 2CH3. So we can write in this fashion, you can extend CH3, CH2, 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 then CH3. So total 6 CH2 moieties or units are present between these two terminal CH3s. So here 8 carbons are present. So we use the root word oct. We use the root word oct. Okay. So we get a root word oct here. And when we have 9 carbons, so substituting here C9, 9 2s are 18, 18 plus 2, 20, so 20 hydrogens and 9 carbons are present. Therefore, we can write the alkane CH3, CH2 taken 7 times CH3, CH3, CH2 taken 7 times and then CH3. So here the 9 carbon chain, the root word is taken as non. Okay. And when we have carbon atoms in the molecule are 10, in that case C10, 10 2s are 20 plus 2, 22. So C10 H22 is the general formula for the alkane having 10 carbons. In that case we can write it as CH3, CH2 taken 8 times CH3. So in between the two terminal CH3s we are going to have 8 CH2s, CH3, CH2, 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 like that you have to write C 8 times and then lastly we have CH3. So total number of carbons, if we observe 8 carbons in between and the 2 terminal carbons, total 10 carbons, and all the carbons are satisfying the tetravalency with the single bonds, sigma bonds. So it is an alkane only with a straight chain. So all these carbon atoms are in a straight chain, arranged in a straight chain fashion. Okay. And in this case the root word is taken as dec. Root word is taken as dec. Okay. And now if you observe, we are adding a suffix ane to indicate alkane family member. So when you add ane to this one, ane to this one, ane to this one, ane to this one, ane to the other one as well. Okay. So when you add ane to these ones, what happens? It is hexane, heptane, octane, nonane, decane. So whenever we write hexane, it indicates that ane indicates it's a saturated compound. It is a member of alkane family, and hex indicates that the alkane contain 6 carbon atoms in a straight chain. Okay, all the carbon atoms are connected in a straight chain. So whenever we have a alkane with the 6 carbon atom, the name is hexane. Whenever we have a alkane with the 7 carbon atoms, we write the name as heptane. And whenever we have 8 carbon atoms, with the write the name as octane. Whenever we have a 9 carbon atoms in the case of alkane, we write it as nonane, and whenever we have a 10 carbon atoms in the alkane, we write it as decane. So root word plus ane you have to write for the alkane names according to IUPAC. First 4 members, in the previous case first 4 members, the root word is given based on the common or trivial naming system, and 5th carbon onwards the names are given based on the Greek numericals, pent for 5 carbons, hex for 6 carbons, hept for 7 carbons, oct for 8 carbons, and non for 9 carbons, dec for 10 carbon atoms. Okay. So the number of carbon atoms that are present in the compound, the name can be derived. Okay. And in the next class we are going to learn the IUPAC system of nomenclature for the substituted alkanes. Substituted alkane. Whenever we have a substitution on the alkane, in that case the names can be given based on the parent name. Okay, the parent chain you have to select. From the parent chain we give the name as based on the number of carbon atoms. So from the number of carbon atoms, it is easy for us to identify the total system or the compound, and then we can easily identify the carbon. So, we can say that whenever we have the different number of carbon atoms. So, in the case of number of carbon atoms, if we are going to use the alk in that case, the case of alkanes. So, here we are discussing only for the alkanes. So, I am writing the root word as alkane. So, the root word should be alk. When we have one carbon, we use the root word meth. So, when we have two carbons, we write it as eth, and when we have three carbons, we write it as prop. Okay. So, when we have four carbons, we write it as but. When we have 5 carbons, we write it as pent, and when we have 6 carbons, we write it as hex, and when we have 7 carbons, we write it as hept, and when we have 8 carbons, we write oct, and when we have 9 carbons, we write it as none, and when we have 10 carbons, in that case we use the dec as a root word. Students, please remember these root words, okay, and of course adding A and E to them will give us our alkane family members. So, easy to remember and there is no confusion at all. Meth, eth, prop, but, pent, hex, hept, oct, none and dec. And of course, we can have, when we have 11 carbon atom, we call it as undec, 12 carbon atoms dodec, tridec for 13 carbons, 14 carbons tetradec, pentadec for 15 carbons, 16 carbons hexadec, etc. So, the chain will continue. We are going to, IUPAC has given the guidelines to write the names. There is no problem in writing the names with respect to the number of carbon atoms, and it is easy for you also to remember these root words. If you remember the root word, you can easily generate the name for a given alkane moiety according to the IUPAC system. So, students, be touch with the online classes, and in the next class we are going to learn about the naming the nomenclature system for the branched chain alkanes, how the branched chain alkane has to be named. All these things we are going to learn in the next class. Then till then, have a good time. Thank you.